Hello everyone, and welcome to today's webinar, Accelerate Viral Vector Production with Benchling. My name is Sean Smith. I'm a marketing manager here at Benchling, and I'm going to be the moderator for today's webinar. Very happy to be joined by two of my colleagues who I'm going to introduce now. Firstly, Prem Mohanty. Prem is a product marketing manager and life sciences product specialist at Benchling, and he coordinates a lot of our efforts in the viral vector production space. We're also joined by Zev Wysotsky, who is a scientific solutions consultant at Benchling. Zev and his team consult with biopharma organizations to scope and configure Benchling for their scientific workflows. Zev, how are you doing today?
Not too bad. Great to be here. Thanks.
All right, good to see you. And finally, I'd like to introduce our guest, Nikita Lim, who is a process development engineer at Audentes Therapeutics. Nikki, how are you doing?
I'm good. Thanks for having me.
Glad you could join us. So thanks everyone for tuning in. I'm personally looking forward to a conversation today on viral vector production, some of the challenges that we often see in the space, and some of the domain expertise that we've built up at Benchling, working with leaders in the field like Audentes. And one quick housekeeping point before we begin. Please feel free to submit questions at any time during the webinar. And you can do that using the Q&A button, which will be on the panel below. So we're going to pause periodically to answer those questions.
Yeah, thank you, Sean, for that introduction. Benchling was really started to accelerate life sciences innovation for the betterment of humanity. Benchling was started by a group of engineers and scientists from MIT back in 2012 who were really not satisfied with the software solutions they had to support their science. With the help of some great VCs such as Benchmark, Thrive, and Andreessen Horowitz, Benchling has really built out a suite of life sciences solutions to really cater to the unmet needs of life sciences R&D scientists. And we are proud to say that we have kind of grown our customer base to include over 350 customers today. That includes some of the largest biopharma leaders in the industry. As we know, life sciences, biopharma industry specifically, has undergone major transformation over the past several decades. And some of our current customers have been pivotal in shaping the new biopharma industry. And we have worked with many of these companies to scale along with them as they build their product portfolios. And because we work with our customers very closely and we are really aligned with the work they do, that has helped us build our domain expertise. In working with many of these customers, we see three major themes that is affecting this, that's kind of rapidly influencing viral vector production. The first is the fact that viral vectors are becoming ubiquitous research tools, whether it is CAR T cell therapy, in vivo gene therapy, or vaccine development. We are seeing an expanding array of applications for these viral vectors. The second theme that we see is that as more therapeutic candidates enter the clinical trials, just the robustness around the process optimization, development, characterization, all of that is gaining much more prominence, and companies are investing a lot of resources into understanding these viral vectors through development. Finally, companies are constantly working towards improving the production methodology, trying to create more efficient methods with higher yield, and even like develop novel methods such as like transient transfection to better address their complex program needs. In working with viral vector teams, we see a few common challenges across a common typical workflow, let's say, that starts from plasmid design through viral production through analytical testing. We see that scientists, especially in the in silico design stage, are kind of, they have issues with needless recreation of existing plasmids because the tools are kind of siloed. Often there's like, there is redundancy in the work performed. And also there's sometimes the design errors are not caught in time. From a process engineer perspective, we see that they are working with multiple different software tools, the data is like fragmented across different systems, and because of which they have to bring together all data from disparate sources to make sense and to create and to make those optimization decisions. Finally, for an analytical lab scientist, we see that they have there's like a lot of redundancy and inefficiency in the way communication happens between the teams. They require like several emails back and forth just to understand the complete context behind an assay request to even get started with their analytical studies. R&D organizations today deserve a modern digital solution that really helps you accelerate your innovation. So, according to us, there are 4 core attributes for any modern software. The first is that it should be able to address your complex science. It should be able to model the complex interrelationships between the different samples that you're working with. Second, the software should be able to really scale with your team. You should be able to support the workflows and the processes that your team works on, and should be able to iterate and scale as your team grows in size. The third aspect here is about enabling data-driven decisions at every level. So for example, if a scientist, designing an experiment and understanding the output of the experiments and the results is key. At a team leader perspective, understanding the program level, like that is key. So software should be able to address the questions at every level of an organization. And the final piece here is around ease of use. We want, ideally, users should be able to adopt the software easily without much hurdles. They see the value in the solution and are able to start using it in a compliant manner with the rest of your R&D IT ecosystem. So Benchling was really built to help you get a complete view of your R&D innovation. We have a suite of 7 applications ranging from a notebook for experimental tracking to in silico design tools to sample tracking and process management tools. Now, all of these applications are built on a single user interface and a single unified platform. Now, this platform, like all these applications, are connected through an extensible data model, which helps map to your exact science and process. And of course, the entire Benchling platform is a 100% cloud native platform, which gives you state-of-the-art security and controls. And the final piece here is that the Benchling platform is open. So we provide a full suite of REST APIs to integrate with your existing IT infrastructure. We have out-of-the-box connectors for lab automation, and we make it easy for you to migrate data into and out of the Benchling ecosystem. So how can we help address key challenges for viral production teams? For a vector core scientist, we can increase the efficiency and accuracy of plasmid design. For a process engineer, we can centralize and optimize production processes. And for an analytical lab, really help simplify the handoffs between analytical teams and the other teams that are putting in the requests to these teams. With that, I will hand over the slides to my colleague Zev to walk us through the rest of the presentation. Yeah.
Hello, everyone. Thank you again for your attention. So again, my name is Zev Wasatsky. I'll be walking us through the viral production on Benchling. First, we're going to discuss increasing the efficiency and accuracy of plasmid design as a vector core scientist. So overall, it is slow and error prone to design plasmid vectors manually. Furthermore, without a database to organize or warn on deduplication of sequences, the efficiency gains above are pretty much lost. And finally, as we all talked about in the poll, maintaining full sequence context for downstream processes is difficult and can be very error prone, if not, having a solution for that. So right now, I'm going to show you how in Benchling the product can or was designed to deliver on these 3 points here. So before I jump into the storyline, first I just want to orient everyone. As Prem mentioned, we are cloud-based. So right now you'll see I'm in my Google Chrome browser in a viral production environment. And on the left-hand side are all of the various applications that Prem talked about, where we can quickly get into various parts of benchling with ease. I'm going to start and looking at our database, as I mentioned, which is called our registry. And so within here is all of the various different object types. So we have genes of interest, pieces of DNA, which vector core scientists are interested in, plasmids, cell lines, viruses, etc. On the left-hand side here. And what I should really be able to do is quickly search and find what I'm looking for, as we're all interested in. So you can see here, I can down select by various different objects. In this case, I'm looking for a plasmid. I will now have a subselection of those plasmids. And you can see on the right-hand side all of the various standardized metadata capture for our vectoral virus core. Furthermore, I want to down select even more. So I'm going to use a piece of metadata and look for a transfer plasmid. And in this case, it's just a drop-down menu. So now that I'm able to find exactly all of the transfer plasmids I'm interested in, I can kind of dig into one specifically and further my science. So what we're looking at here is, this is a direct integration with our molecular biology suite. So you can see all of the plasmid here and any linear maps and sequence maps as needed with the molecular biology tools on the right. And on the right-hand side here, under the metadata, we have some unique and standard metadata capture. So these metadata links easily to these unique sequence parts. And these are autofilled by benchling if we find them in our library of unique sequences. And the accuracy is at the sequence level. So for example, benchling will not allow me to have another nomenclature that matches this, nor a sequence that matches this, even with another name. So for example, let's bring in a new piece of DNA. So what I'm going to do is drag in some unknown DNA. And when I open this sequence, I will be telling it what object type it is. So it's a plasmid. And as I mentioned, we can, because benchling knows certain unique sequence, it'll find all of those. And furthermore, when I try to dedicate this to the database, if a sequence matches, it'll automatically tell me, so I'm not duplicating effort. Now that was done in a very manual and singular way. Let's see how we can do that in bulk. So what we're looking at here now is our bulk cloning or bulk assembly DNA. So we can take a folder of backbones, as you can see here. And here's our triple transfection that we're going to run. A couple inserts. In this case, I'm just doing a control for mcherry, and then finalizing those, making 3 sequences that will be created. So this is really going to help with the efficiencies of generating those for the vector core scientist. And then going back. So finally, back within the plasmid itself, we can, if we go down to our relevant items in the metadata, we can see all of the objects that are referenced, whether they are viruses, other plasmid lots, or the actual way or generation of that. So we can actually, go into the notebook or the experiment that made all of this, see all of the data capture as here. And furthermore, because all of this is linked, talking about the downstream effects, one of the things that we can do with this metadata is utilize our transgene for our downstream teams. So for the process development team, it's important for them to know what transgene are in those viruses. So to showcase this, I'm going to go back to our registry, our database. And what I should be able to do is, again, search for a virus and down select by a piece of metadata that's actually hoisted from the plasmid itself. And as you can see here, I can find all of those. So again, this search is based on what we auto-detect from the sequence and the links that we've created from the plasmid to the viral lot, or virus, excuse me, and not based on a scientist needing to fill this correctly. So we're going to move on to our next process engineer. So typically in viral production, experimental tracking and data collection are reasonably disconnected or siloed. Excuse me. And overwhelming diversity of large-scale data types, which leads to possible errors and delays for scientists entering the results, is a really huge challenge here. And then finally, optimizing viral production is complex because the data, as we mentioned, is siloed. So analyzing these trends, to provide insights and finalized process is difficult. And so I'm going to now show you how Benchling is able to support you in those cases. Great. So this is a templatized entry. We'll just scroll down to the viral production portion. This basically captures the experimental why of the viral production process. And you can see that within the experiment, we have registration tables which directly interact with our database to produce viruses and said virus lots. If we were to go into one of these viruses, we can see all of its own particular metadata as well as all of the viral lots that are produced. And finally, we can capture results against, this one doesn't have it, excuse me, results against them in this table here. So if we were to go into this virus where we've captured our online data, within the results tab, we can not only see the online data that we've captured, but any other data that has been generated via outside of this experiment and others in our group. And so, the structured metadata and results feed into our insights, which is our graphical summaries for these experiments. So I'm going to take us there now. So as I mentioned, all of this metadata and structured data capture within the results feed up into these graphical representations here. So on the left-hand side here, the goal is we're down selecting by virus. I want to see all of my lots. And what I can quickly see is that, virus lot 1 and 4 are producing about half the final titer yield. And I want to maybe understand what the correlation is with that. So if I were to look at the summary, I can correlate that actually the cell bank 1 that is producing both of these viruses, it might be the cause of this. So that really leads me to understand my next experimental hypothesis and either reproducing that or not using those cell lines moving forward. Furthermore, maybe I also have some digital PCR and some time points here, and those also correlate with the data that I've seen above. But really, all of this together is huge challenge for the process engineer to see the full picture of combining multiple data sets that fully describe the viral production quantities and centralized in one view. So really the goal of this is to allow for various dashboards, as you can see here, and helping the process or developmental scientists, excuse me, to see a report-like view. And then finally, we're going to take the view of the analytical scientist. So, it can be really inefficient and difficult to share complete knowledge or context. So during the transfer of experimental information between one team and the next. It's also an inefficient and incomplete view to understand the status of data generated within this process samples. And then finally, excuse me, once the processes are put in place, it's challenging to improve or change them. So again, I'm going to show you in Benchling how we can support you here. So quickly going back to our viral process scientist, at the end, the goal here was to generate some time point samples that we're going to send to our analytical team for testing. Within the experiment, I can actually create what is called a request, and I can quickly send that to our QC team or our analytical team. So what you're seeing here is kind of the experimental context of what we want to do. This is important to me. This is the purpose. You know, how long is it going to take? As well as the rich metadata. You know, we have the viral lot metadata and all of the location information, all directly within Benchling. So typically, scientists are doing this via, you know, a loose meeting or emails, and that information can get lost, specifically for tracking purposes as well. So I have this already done for us, but what you will see is once that request is sent, you'll get an email, or I should say the QC team or the analytical team will get an email, and they can traffic to a dashboard of all of these various different requests that they're interested in prioritizing. So you can see here we can down select and, you know, get to certain things as needed. And if we were to go into one of these, again, you can see the experimental why and all of the rich information that we care about. Once I were to execute, I would use my own templates as a QC or analytical scientists to perform this, and I can choose one or all of these samples to move forward with. So I have an experiment that's already running, and it's here. So what happens is all of those inputs come in as at the top level within my template, and then I can, you know, generate various different experimental why. And in this case, we're looking at an instrument that's capturing data for our viral lots. So we're, you know, getting a final titer, yield, and amounts, all directed within our analytical instruments, and then any other results that have been captured. So the important part here is that any data that's captured within the analytical scientist, because we're using the request, it all gets pushed into the fulfillment tab of the request. So what this means is that the process scientist is automatically getting this information. They don't have to ask whether it's been done or not. They just go here and see if it's here or not. If it's not here, it hasn't been completed, or at least hasn't been entered. And if it is here, then obviously the results are ready to be reviewed. So that really cuts down a lot of time in meetings and helps with the asynchronous. Finally, what I want to showcase is how we might be able to have, you know, team level efficiency or dashboards. So again, going back into my insights, I'm going to look at the how we're doing over time. You can do it. There we go. So what we're looking at here is kind of a dashboard of what's going on. You know, we have various different requests in progress in stat and who's doing them. We also can see, you know, any stage that they're currently in. We want to see them going from a request to completed, and then average dates of when these are taking. So if this is taking quite a long time, we can dig into why. So, you know, overall, this really helps with, you know, resource and management and people and instruments, and, you know, how we need to address the lab, and time to goal throughput. All right. So just to summarize here, you know, we have now shown, you know, vector cloning, viral production, and viral QC testing, those three, you know, stages and personas, you know, important for to have efficient, we talked about efficient cloning, duplication-free database, and the ability to maintain sequence level context throughout the viral production process. We talked about how to centralize and standardize data collection, and then furthermore iterate on the data collection and process conditions to achieve optimal viral productions. And then, you know, how to share complete sample context, the asynchronous results capture and reporting on those, and insights into the team productivity in real time.
Thanks very much, Zev. And I just wanted to call on a few questions that we've chosen to answer live. I think the first one's definitely in your domain. And the question is, what instruments does Benchling integrate with? And for example, can you support real-time data upload from bioreactors?
Yeah. So maybe I'll take the first one, and then Prem, if you wouldn't mind taking the second part of that question. So we have out-of-the-box integration with liquid handlers, so movement of samples, as well as analytical instruments. We probably don't have just as far as what of those instruments, we'd be happy to follow up with a list. But I can tell you that some of the liquid handlers like Hamilton, and there are various others. That's just one example that I can think of off the top of my head. As far as analytical instruments, it's really pretty easy to set those up. So there's an out-of-the-box parser, and it primarily involves some sort of CSV transfer of ingestion of the information from the analytical instrument. And then Prem, would you like to take the online data question?
Yeah, sure. So right now, Benchling does not support online data capture like directly coming off bioreactors, because in our experience, what we have seen is often like a lot of that data needs to be like captured in some location, and like the past version, like an analyzed finished summary version is what is really important for scientists. So we kind of enable you to do that, like collect your raw data, process it, and bring in like the finished data set either through a spreadsheet upload or like copy pasting into Benchling. Yeah, because there are some additional stuff too. Like I know some bioreactors, they have like automatic triggers, like depending on levels of the data coming out. So Benchling doesn't support those kind of functionality yet.
Thanks, Prem. And another question here for you: is the system validated for GXP use?
Sure. So Benchling is fully compliant with 21 CFR Part 11 requirements. So stuff like reviews, sign-offs, audit trails, like timestamps, like all of those features are there in our platform. In terms of the validation packages for full GXP use, that's something that's in development and is coming out very shortly, like within the next few months, in fact. Mm-hmm.
Great. And Zev, we had a question here that relates to your registry demo, which is the metadata field plasmid type something that you created yourself?
That's a great question. So first of all, our metadata, or the registry itself, is a real special part of Benchling, and it's quite unique to our platform. The goal is that we can really kind of model anything. So one thing I can mention is if you saw something that you didn't want to have, or you didn't see something you wanted to have, it's very flexible to change that in about 20 seconds, and then it would update with all of those to all of those plasmids. That model, or this model that we've shown today, has been quite vetted. Quite a few of our current customers are using this model or something very similar to it. So it has a lot of both Benchling best practices as well as scientific best practices behind it.
Great. And we will be obviously pausing at the end for more questions. So I think we've got time for one more. Just bear with me here. Prem, I think this one's for you. Does Benchling focus exclusively on viral vector production, or are you working with other scientific workflows?
Sure. So the Benchling software is pretty flexible and can really map to any kind of science. But the reason we kind of highlighted viral vector production is because this is an example where we really worked with several different customers on this R&D function, and because of which we really understand this R&D function and have been able to create out of the box like data models and templates which helps customers get live and get up to speed quickly. So we do support a variety of different R&D functions beside viral vector, but the reason for selecting some over others is essentially to highlight our more in-depth understanding of these R&D functions.
Okay, great. I'm seeing some more questions pop up here regarding validation and instrument integration. We will answer those via text, and we'll try and get to them at the end. At this point, I'd like to hand over to Nikki Lim to talk us through a case study of how she has leveraged Benchling.
All right. So yeah, hey everyone, hope everyone's doing well. Today I'll be going over how Benchling has helped the Audentes process development team in accelerating viral vector production. But I really think that this can apply to any kind of process development environment. So for today, we'll first start with a quick introduction of what I do in process development. And really the focus of this talk will be on why we decided to look into Benchling, how the period of implementation went, and how we're benefiting from it currently. And finally, what we can look forward to in the future. So focusing in on the process development team, our main goals are process scale up, overall process development, and process characterization. Within process development, we're always trying to optimize and improve our process for making our viral vector product. So this can mean many things, the most obvious being to improve our titer and lower costs. And we also try to stay current with the biotechnology trends and evaluate new equipment that can potentially make our process easier. This includes reducing human labor, providing a more continuous look at our process, and overall increasing our operational efficiency. So to explain the process scale-up work a little bit more, at process development, we operate at the 2-liter and the 50-liter scale, and our manufacturing scale is at the 1,000-liter. So anytime we change the process at small scale, we need to make sure that the process is not only feasible, but will also give us what we expect in terms of performance at the large scale. Finally, as any other company moving towards commercialization, a big focus area is process characterization. So it's important to us as a company, as well as the FDA, to really understand every aspect of our process so that we know what to expect in terms of product quality. It starts with identifying critical process parameters, for example, temperature or pH, and then figuring out how they interact with your critical quality attributes, such as titer. And to do all of this, our day-to-day work involves designing experiments, executing on those experiments, monitoring them, gathering data, and then finally analyzing the data to figure out next steps and how we can move forward. So the challenges that we face when we're doing what we just described are centered really around data entry, data export, and data query or searching for our data. To start with, all of our batch records and data collection are currently done on physical pieces of paper. So while the experiments are being carried out in the lab, our operators would record both offline and online data physically by hand. And once they were done with operations in the lab, they would ideally go back to their desks and transcribe the data into Excel spreadsheets located on Box. Not only did this lead to a lot of incorrect information due to human error, but Box is really not great for searching for information within files. And because the original data is on physical paper, between the time that it takes from being in the lab and to our desk, it can really easily get lost in the labs. So going along with that, our sample inventory and management system was also kept in a spreadsheet on Box, and really it wasn't user-friendly, and because of this, it just never got updated in real time as much as we wanted it to be. And finally, when the experiment is finished, we need to compile all these various paper documents and spreadsheets together, print everything out, and then paste them into physical paper notebooks. So on top of that, if we wanted to do data analysis on a higher level and compile data from multiple experiments together, it really consumed a lot of time because all of our data was in multiple places and it was really fragmented. You can see here all the different forms of data that we have. Our experimental designs are on either physical paper or Word documents. We record our raw material information on physical paper or spreadsheets. Our offline measurements are also on files that we need to transfer from our analyzer machines on USB drives. And our online bioreactor trends are currently recorded in PyHistorian. And finally, we receive our titer data from our analytical development team in the form of an Excel spreadsheet. So for any single experiment, we don't have a centralized place for all of this really important data. So Benchling is a cloud-based solution to our problems. What's really great is that the data is recorded in real time as the experiment is being carried out, and it becomes readily available to anyone on the team once it's entered. Everything from the notebook entry to the individual runs to the materials used in that run are linked automatically. And using the Insights tool with SQL allows that information to be graphically displayed without having to deal with any further data manipulation in Excel or other software that is really cumbersome and is kind of complicated to do. This is just a glimpse at what Benchling looks like. It's really an all-in-one workspace where you can easily go from the inventory to your notebook, as well as additional applications like requests or molecular biology tools. The notebook application really allows us to capture information in real time and condenses what was previously 3 separate forms into a singular notebook entry. And because it is cloud-based, it allows for really good visibility on lab operations, as well as traceability on who worked on what operation. Offline data is also really important to us, and the measurements that we analyze on a machine called the Flex are really crucial in monitoring the health of our cell culture. The data from the Flex machine is in a spreadsheet format, and with Benchling, we can easily import or copy and paste the data into the notebook entry without worrying about any transcription errors. So to visualize this Flex data along with other trends, Benchling makes it really easy with the Insights application. With the use of SQL queries, we can do quick comparisons across multiple batches, which, like I said, can be quite complicated and definitely not as simple and elegant as it is with SQL. And from a management standpoint, the Insights also provides great visibility on not only the ongoing experiments in the lab, but the overall lab throughput or lab productivity. So we can see the total number of batches made for a specific program, as well as a nice visual on titers. So circling back to the challenges that we faced in process development in terms of data fragmentation, Benchling really allows us to unify that data not only in a single experiment, as well as across multiple experiments. So how has this been going on with the ongoing pandemic? Well, our team is currently limited in the number of people that we can have on site in the lab to about 1 to 2 people. This means that experiments really need to be planned meticulously, and operational handoffs and scheduling really need to be communicated very well. The implementation of Benchling happened really at a convenient time. We kind of started around mid-March, and the whole implementation period went very smoothly with pretty low time commitments. One thing that really helped us in comparison to our company's previous attempts at setting up ELN or LIMS systems was limiting the scope to the process development team. The entire period only took about 3 months, and now that we're ramping up our experiments, we're really looking forward to using Benchling to its fullest capacity. As I mentioned, with the limited number of people in the lab, coordination and visibility is really important during this time. And so far, Benchling has really helped us in that regard. Templatizing our operations has made it simple on the operators that are in the lab and has definitely reduced on operator errors. And because there's no more redundant work of data entry and then collecting the data and then printing it out, it has really saved our team a lot of time and allows us to focus on true development work rather than searching for data or kind of administrative tasks. And we've already received a lot of interest from our research, analytics, as well as manufacturing teams. So the expansion to the rest of the company is definitely a possibility. And yeah, that's all I have. I want to give a special thanks to our Benchling implementation team, Aditya and Jeff. They really helped us move the implementation period along, and our go live was at the end of 2 or 3 months, which was our final goal. So thanks.
Thanks so much, Nikki, for that presentation. Really enjoyed that. And a couple questions for you. You mentioned that you went through the rollout sort of during this pandemic period. How did you know when it was kind of time to make the switch to Benchling?
Yeah, so as our team was growing larger and larger, we obviously had more capacity to run more experiments. And with this higher amount of responsibility, we were gathering a lot more data. And once we were gathering a lot more data, we realized that we had to standardize how we were capturing our data, which kind of led us to standardize all of our physical paper batch documents. And once we started doing that, we realized how redundant it was and how really if we had an electronic system and something that was really customizable like Benchling, it would really help us in that regard.
Got it. And so during that process of the sort of implementation, how did you kind of keep scope creep in check? That's something that you mentioned.
Yeah, so just defining the scope of work in the beginning to just process development and just what process development does really helped us in case, we kind of thought, oh, like what if we can do this? We were able to go back to the original goal to help us stay on track and not expand the list of tasks to do.
Got it. And so at this point now, what are the sort of new questions that you can ask or address, whereas prior to Benchling, you could not do that?
Yeah, I think there are a lot of things that we can address now. For example, we can more easily see if certain runs have something in common or if something runs don't have something in common with the insights. So we can easily see, what material lots were used, if there's any lot-to-lot variation. It's a lot easier now that everything's in one place and we don't have to kind of dig for that data.
Got it. And how has that then kind of improved the way that you think about your PD scientific workflow?
Yeah, I mean, it's definitely allowed us to think more about what we can improve on, about where the gaps in our process are, as well as, like I said, if a material has a lot of lot-to-lot variability, we can go back and reevaluate whether or not this material is really the best material for us, or we can kind of reevaluate other vendors. Yeah, it's made it a lot easier to troubleshoot our process. Okay,
well, thanks so much for that. And if there are any more questions from the audience specific to Nikki's presentation, please send them through and I'll get to them. I'm going to open it up to some more sort of general questions now. Zev, we had one come through that I think is in your domain. And it relates to the discussion earlier about instrument integration. So the question is sort of, what about flow cytometers, mass spec, instruments, as well as analysis software, such as SAS, JMP, GraphPad, Prism, etc.?
Yeah. So, there are definitely several ways for you to, import your data from those instruments. As I mentioned, we do have Benchling for lab automation, which will allow you to integrate instruments. Again, we're happy to send out a list if you are interested. So you can use also our REST APIs, which would have more of an automated communication between, Benchling and the instrument. And we also offer, access. So that's the instrument portion. The SAS and the JMP are actually a little bit of a different question. So the way that you would be able to utilize those tools, as we mentioned during our presentation, and Nikki talked about the insights function. So that's based on our read-only Postgres SQL warehouse. And you can hook up any business intelligent tool such as SAS, JMP, other things like that. There's many different flavors out there, Spotfire, and pull that data out.
Great. I'm not seeing any further questions here. Oh, wait, I've just seen one jump up. Would appreciate if you could later on send a list of compatible instruments to webinar attendees. Thanks. Is that something that's from Sean specifically? I think we can follow up there.
Mm-hmm.
All right. Well, if there are no further questions, just like to, again, thank Nikki for the presentation. We really appreciate you joining us today. We are going to follow up and share a recording of the webinar with attendees. And if there are any questions that come up that we did not get to, then feel free to reach out to your Benchling account manager, or alternatively, you can request a demo at benchling.com. So thanks again, everyone, for joining us, and we'll see you at the next Benchling webinar. You can look at all upcoming events at www.benchling.com/events.